Now we are going to see what all the considerations for a generator. So generator, you have to rotate the generator to generate the electrical voltage for running the load. For rotating, we are going to attach a device called prime mover. This prime mover will take the job of rotating the shaft of generator uniformly at a speed omega. Okay, so this prime mover is a device which will take care of rotating the shaft of the generator at an angular speed omega. So the prime mover, it applies a mechanical torque W tau m on the rotor of generator. The armature placed in the magnetic field is made to rotate at the constant speed omega. So because of this rotation of the shaft, you will have electromagnetic voltage EMF is induced in the coil. So if you are going to connect the coil to the external terminal AB, we are going to connect the load across AB. You will have current flowing in the coil. Okay, the load current is going to flow across the RL, and this load current is flowing because of EMF induced in the coils. Okay, and you see three torques here: tau m, tau f, and tau v. So tau m is going to be the mechanical torque on the rotor generator. We'll see what are the other two torques in the coming sessions. Okay. See here the current carrying. See the three torques I said, right? So see this. When the current carrying coil armature is placed in magnetic field, it experiences a torque. So that is going to be called as tau E. That is an electromagnetic torque. This is the reaction torque and it opposes the applied torque tau m. So when you are going to rotate the armature in clockwise direction, definitely an anti-clockwise anti-opposing torque will be developed. Just like how an EMF is going to oppose the source, same way, when you're going to rotate the shaft in clockwise, definitely this tau E is going to be available in the anti-clockwise direction, which is going to oppose your torque. So in addition, there is also a frictional torque tau f that opposes the applied torque tau f. So in addition to tau e, you also have a torque tau f. Tau f is because of the friction between the shaft and the other components of the motor. So by law of conservation of energy, we can say the total applied torque tau m must be equal to tau f plus tau e. So tau f is the frictional torque and tau e is the electromagnetic torque. Okay, so this tau v is only, remember, if you are going to use this device as a motor, when you apply electrical power, this tau v will be developed. But since you are generating this tau v in the opposite direction by rotating the shaft in tau m, this tau v will be developed in the opposite direction because of the it has to oppose the source. That is the reason why you see tau m and tau v are in opposite direction. Tau f and tau v are in same direction because of friction. And by law of conservation of energy, tau m equal to tau f plus tau v. The torque in the clockwise direction will be equal to sum of the torque in the anti-clockwise direction. So if you multiply both sides by omega, you get tau m into omega equal to tau c into tau e into omega plus tau f into omega. And this is how you can see that the total mechanical power is tau m into omega, and because of frictional loss you will have tau f into omega. The remaining actual torque is tau v into omega, which is actually going to be converted into your electrical power, and your coil will have loss, so copper loss will be subtract to remaining. Effectively what you get is going to be v into I. You see here, you put E into I. Now we are having E into V into I. E and V are not same. This value of power will be subtracted with this copper loss. Then only it is going to go for the electrical output. Any doubts you have so far in the operation of generator? So we remember, we are going to rotate the shaft manually. We are going to rotate the shaft manually. So when we are rotating the shaft manually, an opposite torque is developed because of electromagnetic force. So that is going to be tau v. And already there will be a frictional loss as the components are rotating. You will have a frictional torque, which is also going to oppose your applied torque. So definitely, when you are going to apply any force, definitely some opposing force will be there. So you cannot avoid it. The same way here, I am going to have two opposing torque. One is tau e because of electromagnetic induction. Second one is tau f because of friction. So I'm going to say finally that my mechanical power, however, how much ever input I'm giving, by subtracting the frictional loss, that is only going to be available for conversion into electrical power. That is also not entirely available at the output. You have to subtract the copper loss to get the remaining electrical output V into I at the output of a generator. Okay, so we can easily say that the tau f into W is wasted. Tau f into omega is wasted as frictional loss. So now if you write the equation for I is equal to E by R plus RL. So R is the resistance of coil and RL is the load component. And I squared R is going to be your copper loss in the coil. So if you rewrite this equation, you write E is equal to IR plus IRL, multiply both sides by I. EI is equal to I square R plus I square RL. I square R is going to be the copper loss, and I can write 1 I into RL by capital V. So I can write EI is equal to I square R plus IV. Okay, so this equation simply is it is clear that total available power is EI, but only VI is available because I square loss will be subtractive. It will be wasted as the copper loss in the coil. So again, here also you see law of conservation of energy. So but same in the mechanical case in the previous slide, we wrote tau m equal tau m omega equal to tau e omega plus tau f omega. So total available mechanical power is this much, but effectively only tau v into omega is going. The tau f into omega is lost as friction loss. Same way here also, total available power is EI, but what is available actually is IV. This I square R will be going as your copper loss in the coil. Okay, I think any doubt you have, I think things are clear. If you have any doubt, please unmute and ask immediately.